Hello everyone, let's talk about another medium problem on Leetcode today, binary search tree to greater sum tree. In this, we are given the root of the binary search tree and then we have to convert it to a greater tree such that every key of the original binary search tree is changed to the original key plus the sum of all keys greater than the original key in the binary search tree. Then they have defined the binary search tree with following constraints. The left subtree of a node contains only nodes with keys less than the node's key. The right subtree of a node contains only nodes with keys greater than node's key. And both the left and right subtrees must also be binary search tree. So then they have given examples as well. In following binary search tree, we can see there is no element greater than 8. So 8 will be the value in the greater sum tree. Then there is only one value greater than 7, which is 8. So the value for node 7 will become 15. Similarly, we can see that value for node 5 becomes 26 because only 6, 7, and 8 are more than 5. And then we also add 5 to it. So that's why this becomes 26. So this is how the greater sum tree will look. Now that we have understood the example, let's jump into the solution space. The naive approach to solve this problem will be that for every node, we actually find out all the elements which are more than it. So for example, for 4, we will look out for elements 5, 6, 7, and 8, and then add them and then also add it to the node. So this will take like O of n square because we are going through all the n elements and then again finding the elements greater than them again and again. So this is not very efficient. Another approach will be to actually use the reverse Inorder traversal. And let's look at the example to understand why. When we are looking at this tree, we can see that for 8, there is no element greater than 8, right? So the value stays as is. So this is how we fill the greater sum tree for 8. So then for 7, we can see there is only one value greater than 7, that is 8. So we will sum them up and it becomes 15. Similarly, now for 6, the value becomes 8 plus 7 plus 6, which is 21. Now for 5, the value becomes 8 plus 7 plus 6 plus 5, which is 26. So we can see a pattern here. We first process the right child, then we process the root, and then the left child. And the reason for this is we get these values in the decreasing order. If you remember, in order traversal, we go from left, root, and right child, and we get the values in the increasing order. But here we need the values in the decreasing order. So we first process the right child, then the root child, and left child. So how about we actually create a running sum? When we are at node 8, we actually set the sum equal to 8. That will also be the value of this node in the greater sum tree. Similarly, when we go to 7, we will get this sum 8 from the reverse Inorder traversal and we sum it up. So this will give us 15. And now this sum 15 will be used as a sum for node 6, which is the next node in the reverse Inorder traversal. So we will get sum plus 6 for 6, which is equal to 21. Now for 5, the value becomes sum plus 5 and sum till 6 was 21. When we add 5 to it, we will actually get 26. And this is how we will continue filling in the rest of the tree to get a greater sum tree. So that's how the algorithm will work. Now let's jump into the code part. First thing will be, we will check if root is null. Then in that case, we will return null. That's the base case. Then what we have to do is we have to first process the right child. So we will just do bst to gst root.write. Then comes the juicy part where we actually process the current node. We will maintain a variable called sum, which would have accumulated all the values from the right side of the reverse Inorder traversal. So we will just add the current value to the sum. Now just set the root value equal to sum. Then we have to pass these values to the left side as well, right? So we will just do bst to gst root.left, and then we will just return the root. But hang on, where is the sum, right? So we will just create a sum variable inside the class. Now let's run this code. We have to do return null. Cool. Now let's submit the code. Awesome. So in terms of time complexity, it is O of n, where n is the number of nodes in the binary search tree. The reason is we are processing each node only once. In terms of space complexity, it will be O of height, but in the worst case, it will be O of n. And this is because of the recursion stack. Some interviewers may have a problem with some variable being global or being instance variable. So to overcome this, we can also pass some variable as a method parameter. So I've actually also given those solutions on my blog. Do check it out in the link. If this video was helpful to you, please like and subscribe. Have a nice time. Thanks.